Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. I am FileMaker developer certified, and you can see two database modules here for the reciprocal system: the Macrocosmos database and the Microcosmos database. Last week, I discussed the first layout, the universe. This week, I'm going to discuss the second layout, galaxy clusters and groups. Now, incidentally, many of the so-called clusters that astronomers identify are actually composed of multiple groups, which are very slowly separating. We can't blame the observers. It's very hard to detect this very slow motion. So most of these clusters are really comprised of many, many groups. Anyway, let's go through the fields on this layout. Here you can see we have a Virgo cluster, for example, and that's the galaxy cluster name. This would be for the Abell number, which we don't have here, but the NGC, New Galactic Catalog, is 4472. The form number, normally you just have one, but if you want to make a duplicate of this record and put in alternative data, you could hit Control-D, which would duplicate the record. Then you would up the form number, say, making it 2, and then you could put in alternate data if you have a different source. That's pretty unusual, but it's there just in case you want to do that. The location here is the standard J2000.0. Right ascension in hours, minutes, and seconds, 12, 30, and 47.3. The declination in degrees, minutes, and seconds, 12, 20, 13. This is for another catalog of, there are lots of different catalogs out there, believe me. The two major ones for clusters and groups are NGC and Abell, but there could be other ones, but not in this case. Now here we have videos and pictures, and these are sorted by date, actually. Scroll down, I just have a few here. And you could click this for graphs, but we're going to do graphs later when we get to that section of the database, so we'll skip that. And then events, you can add here whatever events you want. For example, here's hot plasma, here's a Markarian chain of galaxies, streams of stars in the Virgo cluster. If you hit, let's do this last one here. So click there, then click here, and you can see this is from the astronomy picture of the day, which comes from NASA. These are in the public domain. So this is answering the question, how do the huge clusters of galaxies evolve, etc., etc. So you can put whatever you want here. And then to go back, you just click on the tab, and you're back to where you were, Virgo cluster. Now the galaxies that are contained within the Virgo cluster are here, and you can jump over to them. Of course, I don't have every possible galaxy, just the main ones that people are interested in. So let's see. Let's go to M90. See what happens. Here's M90. So this is a galaxy. We'll cover this layout next week. So this is a relational database, so you can see that it's easy to jump back and forth. And of course, the parent object down here is Virgo cluster. So that's handy. Now, some more properties of this cluster. Arc minutes, diameter 12, radius in megaparsecs, 1.07 megaparsecs. The radial velocity is 1079, which gives a z value of 0.004. And the dispersion is 757 kilometers per second. Number of galaxies in the cluster or group, it's estimated to be 2,250. So there's a lot more that could be added. Again, I just put in the main ones, but you can add whatever other galaxies you want. The richness class is 0. You can see there's a choice, 0 all the way to 5. The brightest galaxy in the cluster is M87. which is interesting. I don't know if I can have that here. No. So, let's see. Distance away from us, 14.986 megaparsecs, which comes out to 4.886 times 10 to the 7th light years. The distance class is 0. Again, you can go 0 to 6 there. If you don't understand these class terms, you know, just consult any astronomy or astrophysics book. The type of cluster, it's a rich, could be poor, could just be a group. The Bouts-Morgan type, again, you'll have to consult, you know, your standard astrophysics textbook for information on these. RS type, it's I. Percent of galaxy types, this is interesting, so elliptical, percent 12. And these are spiral classes, they're 26%, 62%. Now, luminosity in terms of the sun is 3 times 10 to the 12th, which is huge. Flux density at 1400 megahertz, I don't have that for this. If you have that information, just plop it in. That's in watts per meter squared hertz. Major radio source is Virgo A. Everybody knows that. X-ray luminosity is 0.03 times 10 to the 44 ergs per second. The temperature in kilo electron volts is 2.4. Now the mass of this cluster in terms of the sun is 1 times 10 to the 15th, which is huge. Now I want to say again, this is not just one gravitationally bound cluster. It's actually, it's comprised of lots and lots of groups, which are very slowly moving apart. Now it's difficult to determine these groups, let me tell you, but that's the situation. And here's the number in grams. I'm not even going to read that, just you can see it there on the screen. Now the gravitational limits, the first in megaparsecs is 35.016 megaparsecs, and the second is 129,727.405. The second gravitational limit is that limit at which that cluster would be moving away from us at the speed of light. The first gravitational limit is that point at which, inside of which would be attracted into the cluster, or at least to the groups in that section. Now the Hubble constant, this is interesting. The Hubble constant is not a fixed structure of the universe. It depends on the cluster or the group. For our local group, it's around 72. Of course, there have been many calculations and observations of range, but it's around 72, 73. But for this cluster, if we were there, it would be 0.282 kilometers per second per megaparsec. I have an alternate mass here in case there's a discrepancy. I mean, in a lot of cases, if you check the references, there's a rather strange dichotomy between the different references sometimes for different astrophysical objects. So if you want, you can put in a different one. And then I have a long quote from Larson's The Universe of Motion. The Universe of Motion. Doobie Larson was my theoretical physics mentor. And I'm not going to read this here, but you can see it's a very lengthy quote, so you can get an idea of how the reciprocal system describes clusters. Then we'll jump over here. The mass and luminosity ratio is calculated at 333.333. That is the mass in solar units divided by luminosity in solar units. And there would be an alternate if you have an alternate mass here. And here's the parent object, obviously, the universe. The universe has the universe layout has two basic subgroups. That's the clusters / groups and the voids. And then here are the notes. And I say here the Virgo cluster is not listed in Abel's catalog of galaxy clusters because the redshift Z is too low, so therefore there's no number here. Some sources say that M49 is brighter than M87. See, again, there's some discrepancy. It may be, let me just go up here a little bit. It may be the case that Virgo is actually comprised of a number of galaxy groups which are imperceptibly moving apart from one another, just as I said. Some of the graphs will therefore not work. Yeah. Well, let's hop over. I think the local group, you see. Yeah, the local group is here. Not too many, wow, no videos, that's odd. We got one event. Or beyond the local group. Let's just take a look at this one. That is. And NGC 3621, far beyond the local group. So this is a galaxy beyond the local group. That's kind of interesting. So anyway, here, well, this is one calculation, 64.824, and the other is 77.334. So if you average these out, you get around 72. It's very difficult to determine the masses of these clusters. So you can see the range. That's why I usually say 72 or 73. 72, roughly. Okay, so the galaxies that I have listed here is galaxies of the local group would be Andromeda, Andromeda 1, Andromeda 2, etc. And you can scroll down. I think I have most of them here. Let's see, the number of galaxies, I have 60. Again, the references differ, and sometimes a new galaxy in a local group will be discovered. So obviously there's no, we're part of the local group, so there's no RA or declination. All right. All right, well, that wraps it up for today. Study the reciprocal system and prove it for yourself. For the simplest possible treatment of the reciprocal system, please obtain my work, The Unmysterious Universe. It has all the diagrams, figures, all the concepts, so you can get the basic understanding of the reciprocal system that you need in order to understand more advanced work. Now, if you do want all the mathematics, then please obtain my magnum opus, which is Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. Both The Unmysterious Universe and Existence and Interactions are available at Amazon.com and transpowercorp.com. Existence and Interactions has a PDF file of 711 pages and a PowerPoint file of 711 slides. Thousands of equations, numerous tables, diagrams, figures. It'll keep you busy for months. It only costs $33. The Unmysterious Universe is the cheapest product that we have. It's $9.50. And then come these two database modules. I recently reduced the price of both of these to $95 for the download. It's an amazing bargain for what you get. These two database modules verify the reciprocal system. There are tens of thousands of calculations included in these two modules. So the Macrocosmos database includes all the properties of solids, liquids, and gases. It includes the properties of photons, cosmic elements, and material and cosmic subatomic particles. And just look at the properties that are covered: atomic distance, valence, specific heat, energy and entropy, thermal expansion, compressibility, electrical and magnetic properties, isotopes and spectra. And for liquid, vapor, and gas matter properties, we have volume and density, specific heat, energy and entropy, viscosity and surface tension, and electrical and thermal conductivity. So very comprehensive. And of course, the Macrocosmos database, which is here, I'm going to close this out, covers the universe as a whole. Galaxy clusters and groups, which is just what we covered. Galaxies, star clusters, stars, planets, moons, minor bodies like asteroids and comets, nebulae, gas and dust, and voids. And both packages have a nice graphing package. Then, if you have some interest in economics, my mentor was not only a theoretical physicist, he was also a theoretical economist. And I've made Dewey B. Larson's work in economics also computational. That's my work, Optimal Economist, an implementation of Larsonian econophysics. So if you want to see all the principles of economic science in a mathematical form and easy to apply, that's the package for you. And that's also just $95 for the download now. It used to be $295, now it's $95. It covers the microeconomics of individuals and businesses, business sectors, and macroeconomics of countries and regions. Completely supersedes Keynesian economics, far superior economics. It gives an equation to calculate the amount by which the Fed should be expanding or contracting the money supply in order to keep inflation at 0% or minus 1%. And it shows that the Fed should not be setting interest rates at all. That's nonsense. These artificially low interest rates cause malinvestments. It causes a housing and stock market bubble, which eventually have to crash. So the Fed should not be setting interest rates. Anyway, that's enough on economics, but that Optimal Economist and all these other programs are available at Amazon.com and TranspowerCorp.com. Again, please study the reciprocal system and prove it for yourself. Thanks for your attention.